portion today, and I want to introduce Katie Nalesere.
Thank you.
She is our Division of Aquatic Resource. Are you education specialist?
Yeah,
that's
the
what I thought.
title.
Okay, and our corals expert. Well,
I do my best.
Yeah.
We're always learning.
We'll go ahead
Yep.
and hand the.
Great,
the
thank
over.
you.
Thanks, Katie.
Can everybody hear me okay with this microphone? Okay. So what I want to cover with you guys today, I call this my Kauai Coral Current Events, because coral's been a pretty hot topic on Kauai over the past probably about 2 years. There's been a lot of good information coming out, some misinformation. So I just wanted to come today and kind of share with you guys what we've been learning, what kind of impacts we're seeing on our corals, particularly on the North Shore of Kauai. So I'm just going to go over some really basic coral information to kind of set the stage. Coral is an animal. It's a really basic animal. The animal part is actually called a polyp, so this shows you kind of individual polyps. So together, one coral is a colony of these polyps growing together. Okay, and all they have pretty much is a tentacles, a mouth, and a stomach. Okay, so they're very basic. They're also related to sea anemones, jellyfish, okay, and that kind of animal. And then within the polyps, they actually have an algae called zooxanthellae, and this becomes really important as we talk about the bleaching event that happened this year. So zooxanthellae is a single-celled algae. It actually lives within the polyp's skin, and through photosynthesis, it provides 75 to 90% of the coral's food. So this relationship is really important because without the zooxanthellae, a polyp can't survive, especially because we have such nutrient-poor waters. This is the relationship that's helped them survive in this kind of environment. Okay, so what does coral need? Coral needs clear, nutrient-poor waters. Okay, part of that is because the zooxanthellae does need access to sunlight to produce food. It needs saline waters, which is why by our river mouth, any freshwater input, you see these big holes in the reef. That's because corals can't tolerate that. It needs warm temperatures, but not hot. Corals have a very specific temperature threshold that they've developed within. So too cold or too hot, they can't tolerate that.
What is the, do you know what the range is?
It's about up to, from about low 70s to mid 80s. Yep. And then it needs wave action. So we have areas that we kind of call our dead saltwater, our lagoons. You don't see too much coral development. Where you get moderate wave action is where you find our healthiest, kind of most vibrant corals. Okay, why do we even care about them? One, they're hotspots of biodiversity. I'm sure you guys have heard them called the rainforests of our ocean, right? 33% of animals, marine animals worldwide, rely on reefs as juvenile habitat. Okay, so it impacts all throughout our ocean. We find more diversity on our coral reefs than anywhere else in our oceans. It provides habitat for a lot of our marine wildlife. Okay, shoreline protection. You guys know that's especially important up here where we have our huge swells in the winter. Tourism. This is actually in our PADI magazine from middle of last year. So it's called Kauai, the Next Big Thing. And it highlighted our monk seals and also our reefs. Okay, cultural uses. A lot of our traditional Hawaiian Pacific cultures use items from the reef in cultural practices. So to be able to perpetuate that culture, that practice, we need to have access to those resources. So it plays a big role in our social lives. And also just resources for food, right? I'm sure a lot of you guys eat reef fish, lobster, all of that. And I think the number is something like 5 million people worldwide rely on reefs as a food source. Okay, so what stresses out our corals? One, like we talked about, fresh water. So that could be a natural thing, big rains. After big rains, you might go snorkeling. You'll notice the corals aren't as vibrant. Okay, and that's because they really do not like fresh water. Also the sediment that it carries with it, because it minimizes their access to sunlight, and two, it can actually settle on the polyps and that will irritate them. Okay, also physical damage. Again, this could be a natural thing or a man-made thing. This shows a reef before and after a hurricane. So you can see corals, they've adapted to survive through a lot. They all, for the most part, are in hurricane-prone places. So they do have adapted with physical damage, but certainly we've exacerbated that through walking on the reef, anchor damage, marine debris. Okay, resource extraction. It's another name for overfishing. Just as we take out, kind of this picture highlights it a little bit. These are all herbivores. So one of the things, like on Maui, you may have heard about the herbivorous fish management area. A lot of our reef fish we target are herbivores. They keep algal growth in check. Coral as an animal is really slow growing. It can grow from some as little as 1 centimeter a year up to 40 centimeters a year, but that's a very fast one. Average growth is about 10 centimeters a year. Compare that with an algae, they can't compete, right? So when we're taking out a lot of our herbivores, we're allowing algal growth to go unchecked, and they can outcompete coral. So that's just one way overfishing has an impact on our reef. Also resource extraction and kind of the physical damage that goes with that through nets, through discarded fishing gear. And fishing gear, this is one of my favorite facts I always tell the kids. I usually work more with kids, but fishing gear, it actually takes 600 years to break down. That's how strong it is. So that's pretty mind-boggling because that is a huge issue. And I've even heard nene have been found with a lot of fishing gear. I don't know if you guys see it up here around their legs, but I've definitely seen it on turtles at a nini. We had one where the fishing line was actually cutting halfway through its flipper. So fishing line, especially discarded by accident or on purpose, is really a threat. Okay, and then last one, we hear all the time climate change. And this has multiple impacts on coral reefs. One, increasing sea surface temperatures, and that's one that we'll talk about a little bit more. Two, ocean acidification. So corals, calcium carbonate structure, it's essentially the same thing as our bones. And some doctors can actually use pieces of coral to replace shattered bones in surgery. That's kind of an emerging medical use for coral. So it's not, what's that?
Say that word again. Acidification.
Acidification, yeah. So our waters are becoming more acidic, and because the structure isn't that strong, it's actually breaking down. We're not at that point yet, but it is kind of weakening the coral structure.
That's because the carbon in the air gets absorbed by the ocean.
Yep.
And increases the acid.
Yep, exactly.
Carbon.
So, yep. So that's kind of the two main impacts of that climate change is having and is predicted to have more on our coral reefs. And then last but not least, land-based pollution. For multiple reasons. One big one, again, being just eutrophication. More nutrients are going in our waters. This is giving algae an edge over corals. It's kind of throwing off the balance within the ecosystem. It's a very fine-tuned ecosystem, so any way we change it has huge implications. And this just shows you some algae growing over a coral. Okay. That's kind of our very quick overview of that. Now specifically to the North Shore, we do have a very interesting coral reef environment. We use the word dynamic a lot, and that's because we have such high wave energy in the winter. Okay, and it's a hard place for coral to develop, and because of that we don't see too many really fragile shapes, a huge diversity of species. Because it is harsh. It is a difficult place for coral to grow. And this also, freshwater influx is pretty big, high turbidity, and because Kauai is so old, we do have a lot of sediment going into our oceans, naturally, and then also through development. But, I mean, if Kauai is 5 million years old, we call her a big old lady, right? She's eroding, and with that, that's a lot of impact to our corals. So overall, we have a low coral cover. It's only about 14%. And we have had researchers studying specifically Hanalei Bay for about 20 years. So that's numbers that they've come up with. They also found our corals are self-recruiting, and this is really important. That means that they're just their spawn, their larvae is coming back and settling back within the bay. They're not getting larvae from other reefs, which means that any impacts, if we have a disease, something else that kills our corals, there's not new recruits coming inside. So it makes it a very at-risk ecosystem for that reason. Okay, so we're going to talk about two main issues that have come out over the last few years. The first one is a coral disease. So we call it our black band disease, and you can see it has a pretty distinct black band. Okay, that's how we identify it. Just a couple of basic things about coral disease. Because they are animals, they are alive, they are susceptible to disease, just like anything else. And disease, to a degree, is a natural aspect of populations. Okay, and this just kind of gives you the definition. I won't read it. This shows you some of the main diseases that we see. Tissue loss, growth anomalies, so essentially tumors on our corals, and discoloration. Okay, and then how we define our different levels of disease. First are our background levels, and this is what you can expect to see in any population, right? Any given day you go into a town, somebody's going to be sick, right? That's just how it goes. That's background levels. Outbreak levels is when we find the disease in excess of what we would expect, okay? And then epidemic levels is when it substantially exceeds these two, and when we've talked about the Kauai coral disease, we've used both words. Some researchers will use them interchangeably. We kind of say what we have right now is an outbreak. Okay? And then last is a pandemic. So that would be if we found this disease across the Hawaiian archipelago or even other countries as well. Okay, so when we talk about a disease, we're really focusing on a triangle. For a disease to be present, we need three things. We need a susceptible host, we need a conducive environment, and we need a pathogen. Okay, and we'll kind of go into those each a little bit more. Okay, so this just kind of shows you coral disease worldwide. It's been on the increase as we're having more stressors to our coral environment, and it was listed as one of 6 priority areas for the U.S. Coral Reef Task Force. So you guys can see, I mean, it's pretty spread across where we find our corals. So coral disease isn't super uncommon, but it is definitely on the rise. And these are just some of the ones we found in Hawaii so far. Okay, so you can see some of the ones we talked about. We've seen tumors, these discoloration. We also call that coral pimples, and that's just where a coral gets irritated. So it could even be an algae, it's just the waves are pushing it against a coral, and that's how it shows irritation. Then we have some other tissue loss diseases. So in total, I guess we've had 18 different diseases observed across Hawaii. Okay, and this is our black band disease now. So again, this gives you a bit of a clearer picture. We have our live coral, this black diseased lesion, and this is dead coral. So typically this disease will move across a coral in a semicircular pattern. So I'll kind of start out on top and just kind of progress down. This disease, and initially we called it a black band-like disease because we couldn't confirm that it was actually black band disease, was observed in 2004 by UH and NOAA divers. So we've known about it for about 11 years now. But initially it was in really low levels, and then you can see after 2009 it really took off. So we could say this was kind of background levels. This shows you again how many cases were observed between 2004 and 2009. And this was through, if you guys have heard of our CRAMP or RAMP surveys that NOAA and UH does annually or every 2 years, I'm not quite sure. Okay, and this shows you where it was initially found. Okay, so orange spot was where it was observed in 2004. In 2008, it was observed here, and then red was 2004 and 2007. So it's kind of that, moving that way. Okay, then in 2012 we got a report through Eyes of the Reef Network. Have you guys heard of Eyes of the Reef? Okay, for those of you that haven't, it's a community, it's almost like a community watch. People get trained in how to observe coral disease, bleaching, or other kind of issues, and then they report it to researchers. And we've laid out a rapid response plan now. So when we get these reports, we actually have a process we follow to respond to them. So in 2012, we actually had a member of the public through the Eyes of the Reef Network. He started giving us reports that they were finding this disease at pretty high levels. So this kind of kicked off our response chain. So we had a couple of questions when we got these. First, is this really black band disease? What is the spatial distribution? Where are we finding it and at what levels on Kauai? Which species are affected? What is the rate of the progression of the lesion? How virulent is it? And who are the pathogens involved? Okay, so first we wanted to know, is this really black band? Black band has been around for a while. It's been observed in the Caribbean, Indo-Pacific, and Red Sea. So it's not a new disease. Okay, it's not host specific, which means it can target a variety of species of coral. It consists in a microbial consortium, which means it's not just one bacteria acting by itself. It's multiple different things acting together to create this disease, and it creates a sulfate-rich environment. So through UH researchers, Chris Runyon is the main person. She's a PhD candidate, and all of her work has been done on this disease. And through Terry Work, who's with USGS, you probably know of him because he does a lot with birds as well. They actually isolated the bacteria, and they did confirm that it was a cyanobacteria that's 99% similar to the cyanobacteria found in other coral diseases. And then they also found that we did have these two other things that were creating a sulfur oxidizing bacteria and a sulfate reducing bacteria. So with these two things confirmed, we know that it is actually black band disease that we have. And it's only found on Kauai, so just here, not any other island. Yep. So we wanted to know, where is this disease actually happening? So these were the survey sites. So between all of 2013, they visited all of these different sites to try to identify, was the disease present or not? And this was the result. So all of the red pins are where we found the disease. White pins is where it wasn't. Okay? Was not, yeah. So you can see there's a pretty strong geographic trend here. It was pretty much focused on the North Shore, with the exception here, which is Ahukini. Okay, no surprise there. It's a difficult environment. There's actually beautiful coral there, which really surprised me. But you can see that's pretty, and actually since then we found it at Anahola and in Moloa'a Bay. Okay, but it's pretty much on the North Shore. It has not been observed up till now on the South Shore at all. Okay, this site was also interesting because we're going to get into why are we finding it here and not here, right? And a lot of these times we think, oh, development, but actually we found it on the Pali Coast too.
What year was that again? I'm sorry.
This was 2013.
Oh, so, and just recent, in 2014 you found it?
In Anahola and in Moloa'a, yep. But we also did more dives around the Kapa'a, Wailua area, didn't find it there. So, and south, they've revisited those sites and still haven't found it there yet. Okay, and this kind of shows you the prevalence at the different locations. We actually have hot spots of occurrence. We'll have places where it's much more prevalent, even within one single reef. Like you can see Ke'e, 1 and 2 had no black band disease. 3 had black band disease. At the highest level, we've seen it. Okay, so it has hot spots of occurrence. It's not uniformly across the corals. That's pretty interesting. You can see Anini is another place, and Makua. So those are kind of the 3 hot spots that we've identified this disease. And actually Anahola is pretty high too. We don't have those numbers back yet. But it's pretty high. So we said, are we just finding it here because that's where the coral that hosts this diseases or no? So they surveyed, and actually there's no link between host abundance and disease abundance. Okay, so that's kind of helping us narrow down where to focus and why it might be somewhere and why not. It has nothing to do with host. Okay, because you can see this is South Shore. It actually has a higher average Montipora cover, but still no disease. And North Shore, lower, but higher levels of disease. Okay, and this just shows disease distribution and prevalence throughout the years. So we also wanted to, you can see 2012, we had 6%, 8 of 133 colonies were diseased. By June 2013, 1 in 122 were diseased. This is also trying to help us figure out what are the drivers. Is it seasonal? Is it cyclical? What is happening? And actually we don't know that yet. Okay, then we wanted to know which species are infected. So if you remember when we were talking about black band in general, it's not host specific. It can target a lot of different species of corals. Here on Kauai, this disease has only focused on rice corals and 3 species. So we have our Montipora capitata, Montipora patula, and Montipora flabellata. And they're all Montiporids. Okay, so we've only found them on those corals so far. Nothing else. So that's also interesting. Why only Montiporids? We don't know that yet. Okay, then we wanted to know how fast is this disease progressing. So this is one way that the researchers studied it. They put a marine epoxy along the dead coral, measured how far away it was. This was the day they did it, May 30th, 2013. And then 6 days later, they came back. It migrated 3 centimeters. Yeah. So it's actually a pretty, when the disease is active, it's a very fast-moving disease. So that makes it move about an average of 6.5 millimeters per day. And you can see all of that is just dead coral. Pretty sad. Then they wanted to know how virulent is the black band disease. So they actually did laboratory trials where they took pieces of Montipora and actually tried to infect it with the disease. Okay, and actually they were able to infect 17 of 18 corals. So it is fairly virulent, but they did actually have to cause some physical damage to the coral. So the coral healthy wasn't able to be infected, but when it became stressed, 17 of 18 were infected. We don't know. But I mean, it is really important to think about coral just like us. When we're stressed, we're more likely to get the flu. Corals are the same. When they're stressed, they're more susceptible to this disease and to any kind of disease that's out there. Okay, and this just shows you a picture from the field. So this is an untreated colony, October 1st. Then you can see it November 28th, May 29th. And you can see that it's it's gone essentially, right? This is the only live bit left. So you can see kind of just going back. You can see this is the disease here. Here's the live coral. This is probably more recently killed coral. You can see this little remnant remaining. And then by May, that was all that was left.
This all says untreated. Is there a treatment?
Yes, so this is something else that they were trialing as a part of this study. So this is the colony before treatment. They actually tried to make a treatment with marine epoxy. It's actually mixed marine epoxy with bleach, a little bit of bleach, scraped off the lesion to get the bacteria off, put this down as a patch, and then essentially made this line as a fire break so that if the disease bled through into this coral, this would hopefully stop it. Okay, so this was one of the things that they've tried, and it actually worked. So this shows you a month later. And then in May, you can see it's still alive. That was the already dead part, but this part is still alive. And there's actually CCA settling on that epoxy now. And CCA is the algae that's it cements the reef and allows for new settlement. And they've even since seen the coral growing back over that epoxy again. Yep. But this is really a Band-Aid. I mean, by the time we caught it, there are so many disease colonies. This isn't a realistic option, but it does give us good information for addressing future diseases. Okay, and then this is the way that they've been analyzing the amount of tissue loss on corals. And this just shows you untreated versus treated colonies. So these are some of the colonies that they've tagged and revisited. So case fatality rate in untreated colonies was 25%, meaning 25% of the total corals tagged just completely died. Morbidity rate of the colonies, 100%. Average amount of tissue loss across all of them was 65%. And that was the range. So it ranged from as little as 12% to 100%. Okay, within the treated colonies, none of the colonies died completely, which was good. Morbidity rate was 50%. Average amount of tissue loss was only 4%. And then the range was 0 to 35%. So again, if we catch these diseases early, this could be a potential treatment. I like the music though. So this is kind of what we're doing now. We're trying to monitor these colonies to further understand virulence, understand is there a seasonal difference, and is there a difference between how these three montiprid species respond to the disease. Okay, and this is, I like to call this my charismatic coral. We call this guy Big Blue. It's a coral out at Anini that we've been tagged and monitoring for a couple of years. This is July 2013. You can see it has an active disease lesion on it here and here. March 2014, we went back, no disease, no active disease. And you can compare the colors. It's light here, which kind of shows it's a little bit stressed. Here, which shows it's doing really healthy. August 2014, we went back, still dark, and these light edges actually show new growth. So that was really encouraging for us. And then we went back in December, and you can see the colors changed a lot. We're actually going to talk about this more. So it's partially bleached. So we're going to go back soon and see how it's doing. But Big Blue's still hanging on, so that's pretty encouraging. So now just coming back to this. We know who our host is. We know that we have an environment, but we don't know what makes our environment conducive, and we know what our pathogen is. Okay, so now we're really trying to find out what is the driver. Okay, we know which corals are affected, we know where they're being affected, but why here and not other places? You know, and realistically, this disease has probably been around for a while, but why is it broken into outbreak levels now? What has caused that to happen? And it's very complicated, just due to the nature of coral reef environment. So these are some of the things factors that they're working on mapping out right now. And I'll show you what we've found. And also they're doing aquaria studies. So they actually do at HIMB, they have samples from here and they're manipulating the environment to see how the disease responds. So far we have been able to look at total suspended solids, found no correlation. They looked at sediment and measuring turgeneous sediment versus marine. No correlation there either. Water temperature, no correlation, slight correlation. And then water quality data, they've taken the samples that Department of Health and Surfrider does, tried to match that with where we're finding disease and not, and no correlation there. So the only one is a slight correlation between temperature, and this shows you kind of the levels of black band disease. So it's not consistent across the board. We have times where the disease is active and times where it goes dormant. And then this is temperature. So you can see that they follow kind of similar trends, and that's one this is kind of the newest finding, so it's one that we're going to study a bit more. Okay, and this just shows you their Aquarius studies that they've been working on as well. Okay, and last they're actually looking again at host. Because we were talking about Kauai the North Shore specifically is self-recruiting. This is a study done with OPHE between the different islands, and this shows the barrier of recruitment. So these islands will help recruit each other. Kauai because we have such a large channel, we don't get recruits from other islands. So genetically, we're more isolated. And then on top of that, the North Shore corals are self-recruiting. So is there something genetic within these corals that makes them more susceptible than other ones? So we've really been focusing on the environment, but could it be a genetic thing? They're just very genetically isolated corals, and that is what allows them to become susceptible to this disease. It's a bit more complicated to study, but we do have people at UH starting to look at that now as well. Okay, so that's kind of our coral disease. That's where we are right now, still working on it. They started doing water quality testing to look at nitrates. So I had more studies to figure out drivers, and we're going to start mapping additional factors. And we'll have USGS coming in as well to do some work with freshwater lenses, and if that can correlate to where we're finding this coral disease. Yep.
This might be a really naive question, but have they started to look at any possibility of sort of farming corals and recruiting from those other islands and sort of bringing corals in, sort of importing in any way, or is it too early to even consider that?
That's a good question. I do think it is too early because until we figure out what's causing it, we just be bringing in corals to be exposed to this as well.
From a biological point of view, is that possible to sort of farm corals?
Oh yeah, yep. Here it's very difficult. I used to live in the South Pacific, and we have very fast growing corals, and our water's a lot clearer just because of the nature of the environment here. Farming coral is very difficult, and I don't know if anybody's really found a very effective way to do it yet. But it is something that people are working on. And I know they're looking at it now too in Kaneohe Bay, because as they do the super sucker with that invasive algae, the coral fragments get stuck in that algae and get broken off, so they're going to try to look at replanting them now. Yep.
One of your charts showed this rapid increase in the disease starting in 2009.
Mm-hmm.
Was the level of sampling constant through time, or does that chart allow for different levels of sampling?
That's a really good question.
Can you repeat the question,
Oh, sure. The question was, in 2012 when there was a trend, was that because of increased sampling, or was it necessarily that the disease was on the increase? And I think it was because they had done surveys at other sites and not observed that disease. When they went back in 2012, that disease was present. So I do think it was actually an increase in the disease as opposed to increased sampling.
And you showed lack of correlation with several factors.
Mm-hmm.
Has there been any attempt to correlate this increase with social, economic, or cultural factors?
That's
that happen
yep.
on the island?
That's the next phase, and we're continuing to add factors in and keep mapping them out. So I think that will be happening over this next year. Yep. Any other disease questions? No. So we're going to go on to our next event, and this one I don't have quite as much information on, but it's been one that's been in the news. So our corals got a double whammy this year when we actually had a mass bleaching event throughout Hawaii. This picture is not from here, but we had a team from, I believe, Australia come in, and they specialize in underwater imagery, so they actually made these large panoramics of the reef. So it just kind of shows you the bleaching. So what is bleaching? Going back to our coral basics, bleaching is when the polyps get stressed, and they're stressed to the degree where they feel like they can't house that zooxanthellae anymore, and they actually throw it out of their skin. They expel it from their skin, so the polyp part is still alive, but it doesn't have that symbiotic algae anymore. And if we think back, that algae provides 75 to 90% of the coral's food. So a polyp can feed on its own. It can provide 10 to 25% of its own food, but over a long period of time, that's not enough, and the corals will essentially starve. Okay, so if whatever is stressing the coral passes, they can actually bring that zooxanthellae back inside their skin. They'll reabsorb it, and it can completely recover. If that doesn't happen, the coral can die. Okay, and this just shows you a really clear picture. You can see it's white. See all those little dots? Those are all the little individual polyps still inside, still alive, but no more zooxanthellae. And we call it bleaching because polyps themselves are clear. They have no color. So when there is no zooxanthellae alive, they're just this really bright white, like a piece of paper. And they're so bright you can see it just from shore when you look out over the corals. You'll see these really bright patches. That's bleached coral. Kind of how we were tipped off to this bleaching event was first NOAA puts out this bleaching alert and outlook. So in October last year they gave us this map, and you can see especially Kauai, we're on high alert for bleaching. And
What triggered the alert?
they just look at sea surface temperatures. Yeah. So typically mass bleaching events, especially on a really large scale, are due to sea surface, increase in sea surface temperatures. Yeah. Corals can bleach at other times. If you dive, like I was saying, after a big rain, you'll notice coral colors aren't as vibrant. If you've had any really large freshwater input to a place, you might notice the corals will be slightly white. And that's, again, they're just stressed out, but that kind of stress typically passes pretty quickly, and then the coral will get all of the zooxanthellae back and recover. Also in summer, if you compare snorkeling in summer to winter, you'll notice the color changes slightly. Corals are a little less vibrant in the hotter months. And that's just due to their sensitivity to temperature. And this just shows you average sea temperature range for Hanalei Bay. So average temp is about 80 degrees. This is the range 78 to 81 degrees. Last year in October is 83 degrees. And so there's only 2 degrees difference, but to coral that's fairly significant. Okay, and again, Eyes of the Reef started sending us reports as well. And this, we got over 100 reports actually across the state, which is probably our biggest number of reports we've gotten for any incident. And this helped us kind of prioritize which sites we wanted to study and focus on. Okay, and this shows you just the severity of bleaching. When we started doing our studies, we were looking for any degree of bleaching. Okay, so this is a fully healthy coral. This is a pale coral. That's that blue rice coral, right? We saw in one picture it's kind of that dark purple color. When it bleaches, it turns this bright lavender. Okay, so just paling coral is a sign of a stressed coral. Then we gave level 3 to kind of partially bleached corals. Typically, you'll see corals will bleach at the top, right, where they're most exposed to the sunlight, heat. And then underneath, sometimes the corals can retain their zooxanthellae. And then level 4 bleaching is just the full colony is bleached. Okay, so we focused on 4 sites for our studies. 2 at Anini, Lepe'ule, which is also Larson's, and Anahola Beach Park. And we did our first surveys in October. We found 50 to 90% of the corals were bleached. And that's any of those levels. That means some were pale, some were totally bleached. But then average of 50% of the bleached corals were severely bleached. So that's at level 4, where the full colony is white. So we kind of got our baseline there. We also had efforts in Kaneohe Bay and on Maui doing similar studies to look at where the coral was bleached and to what degree. We actually here did go South Shore too and found very few corals bleached. So it was again primarily on our east and north facing shores. Once we identified those, we wanted to monitor recovery. So this kind of shows you again that life cycle that corals can go through. If whatever stresses it out passes quickly, corals can make 100% recovery from bleaching. So after October, we went out again in December. Temperatures had dropped to 77, which is a pretty rapid drop due to some of the storms that we had. And so luckily, the majority of our corals were able to recover. So this shows you just a colony. This is October. A week later, it's already starting to recover a little bit. 10 days later, it's even darker. And then by November, it's pretty much recovered, okay, with the exception of a few tips. And we did find that different species were reacting differently. So we have one kind of coral called Pachylepora damicornis. It just is really tiny. We call it lace coral too. Almost all of those did not survive this bleaching event. But then a lot of our other ones were able to recover. So different species actually reacted differently too during this bleaching event. And then in the future, this is actually from a NOAA article yesterday, and this shows you just how sea surface temperatures differ from average. You can see Hawaii, we're about 0.5 to 1 degree above average temperature, and we're expected to have El Nino next year. So we can anticipate that we may have another bleaching event. And so this is really important because this is something, we have had mass bleaching events before worldwide, but we're expecting them to happen more frequently and more severely as the impacts of climate change become greater. So this, we were very lucky. We saw a lot of recovery. I think we learned how to respond a bit better and get more information about bleaching events, but we do anticipate to be having this happen more and more in the future. So that's just another thing that's hitting our corals. And one thing we wanted to know was, we had this bleaching event, our corals were stressed, how is this going to affect disease? Because this kind of does weaken the corals, it makes them more susceptible to disease, and I don't think we know yet. So far we haven't observed an increase in the disease, but we haven't had any big surveys done yet since the bleaching event. So that's another thing that we're going to be looking at. Okay, so that's the end of my presentation. Do you guys have any questions? Thank you.